Video is gonna be very formal. I'm gonna try to do the concept of the framework we invented. But this video is gonna be on um, that's called quantum field theory, principles of dimensional codec. Uh, quantum field theory, principles of a dimensional codec. Without further ado, let's get started. Today's date is the 19th of April, 2026. Time now is 12 a.m. 12 a.m. So we're gonna be talking about dimensional principles and principles of dimensions. The term dimension refers to the heterogeneous, homogeneous uh, lattice we all lie on, known as the Higgs field, which is responsible for giving their mass, responsible for giving particles their mass. What does this mean per se? The heterogeneous, homogeneous lattice we lie on, Higgs field, is known as gravity. And gravity is a system that dictates what mass an object has. The Higgs field is the from the is what is used to dictate what is on a system that expresses what's in the mass. For example, if I have a tennis ball and tennis ball on one hand, and uh, uh, and then I roll that down and roll that down to the center of a basically the if I have a tennis ball and I push that into a system, you know, push that roll down to the center of a disk. Everything has a gravitational pull. Well, that gravitational pull is represented by the Higgs field, and the Higgs field is what we all share, the fabric of reality we all share. If I take something that's soft, my idea is soft and smooth. Not soft and smooth. A soft and smooth is because soft and smooth implies it's soft and smooth. So soft implies that's hard, that's rough and smooth. So a tennis ball is rough and smooth. A softball is soft and smooth, and a golf ball, a table tennis ball is soft and smooth. So you get a table tennis ball. A table tennis ball is soft and smooth. And what I'm implying here is, if you have the two balls and you drop them at the same time, you have the Higgs field determining dimensions of the opposite, but you have to compute it over. What do I mean by that? Okay. So think of the formulae. I'm going to try to calculate this formula. If I'm wrong, just bear with me. This is just an introduction video to the whole system. But in this formula as possible. So if I have half a dimension, one divided by x maps to x. So one divided by x implies one half of the ratio of a system maps to the scale of a system in a dimension. You have the four scaling factors: rotation, reflection, enlargement, and rotation, reflection, enlargement, and translation. These four properties of dimension is what dimension principles are about. For for XYZ systems, any kind of XY system based on longitudinal meaning it propagates as the y-axis first, polar propagates y-axis, and longitudinal latitudinal systems. So y then x. So a y component before an x component as an order of the lattice. Now, these are homogeneous bound by the heterogeneous and homogeneous kind of data. Also recording. And to say the least, this longitudinal propagates as longitudinal wavelengths and latitudinal wavelengths, longitude then latitude, based on the principle of uh, geometry of the curvature of the Earth, like longitudinal. It's not probably longitudinally, it's probably along the curvature of the X, but of the y-axis of the north to the southern north to the southern hemisphere of the Earth, and the latitude is coming from the west to the south, west to east hemisphere of the Earth. So you understand these are properties of operating system via cubic length. And what Muko OS represents, the brief sequence is that the way it propagates can be heterogeneous and homogeneous based on the type and kind relationship of a system. I'm busy. I'm coming late. Thank you. For example, think of example as I'm expressing the one half dimension, one half d to two as a ratio of the back to the tennis ball, the tennis ball, the table tennis ball, table tennis ball, which is a soft, no, which is a hard, which is a hard and a hard and smooth ball, and the soft ball is a soft and a smooth ball, like smooth surface ball. You know, when they encounter the Higgs field, they have responsibility. That is the behavior of the system. But the behavior is heterogeneous, homogeneous, based on just the quantum field theory principles of dimensions of having a constitutional system. Think of a plane, and that plane. They think of a plane. Think of think of so as a model. I'm proposing that the Western system is longitudinal, and latitude to longitudinal system. From west to east is longitudinal. Because longitudinal, there's a peer, this quantum field theory model of a Higgs field, and this Higgs field enforce like the quantum field theory diagrams that express cause and effect duality. Is it an effect or cause? I'm expressing that when you have two balls, soft and smooth, and the time it takes is a principle to understand is kind of why the system was there to ensure isomorphic traits especially relationship between isomorphic principles. For example, uh, I'm trying to formalize how a cause and effect via a Feynman diagram when the particles interact. For muon, for muon, let's take the term. Okay, so the soft and hard ball, the hard and smooth ball, a hard and smooth ball, which is a tennis ball, comes in contact without a Higgs field, without any Higgs field, a hard and smooth ball which is a table tennis ball, comes in contact with a soft and smooth ball. this comes into contact, comes into contact on a domain without any kind of dimension in place, without the Higgs field in place. What would be the effect of the system? They'll just bounce off each other without any kind of mass, without the mass, without creating something new. But there'll be a cause and effect relationship that resolve kind of the muon. Because let's take the substance mu ball and replace it to muon, a muon, and a twelve. 12. So the a muon is so you got a lepton, which is 0.98 milliseconds of drop time. Electron is a muon. Electron is 0.98 9.8 milliseconds of milliseconds per gravity. But this doesn't really mean anything if it's this is bound by the dimension, or this is bound by dimension of measurement. The key separation concern is that the muon, which is 0.98 meters per second, and the lepton, 0.98 meters per second, 0.098 meters per second. Let's say smoothness. Let's just take two muons example. A muon of 0.98 meters per second and 0.98 meters per second has and a simple position. And they are. I'm just experimenting. They are spun. They are entangled in simple position, and that's because entangled. I'm busy. I'm busy. Come back later. Later. Sorry, 1 second. So the idea of what I'm trying to get the formal framework to spread the cause interaction between particles that propagates that result in a kind of resultant waveform that when via a Feynman diagram. I love the Feynman diagram, but I can't get to do them, so I'm going to do them my way, because I don't really know. I can't really put in the formal framework of the Feynman diagrams. So the two muons have a spin. They are 0.98 meters per second. When you drop them in a dimension, and the dimension is operated as a lattice. So the dimensions are again the things the codec the coder and decoder of the environment. So what I mean by this is that there's kind of a formal coding of a system that expresses that analogy. For example, you cannot for one system, for any kind of system, you have there is a codec there, and that coder and decoder is expressing is expressing the dimension in a dimension. That dimension can be any kind of physical dimension, such as a physical system. It can be very important in STEM. It can be physics-based system. So, for example, it's say you are trying to take a measurement. Any kind of physical system. For example, we can talk about force equals. If you take the model of a dimension. Example, dimensions are things you operate on, so you operate on dimension. For example, the Higgs field is one dimension because that dictates the gravity, what the gravity will be, what the graviton will be. But because everything has a gravity, and everything, the job of the Higgs is just to give particles their mass. So how I'll try to do it myself. If you have if a muon was spawned by half, if a muon was spawned by 2/3, 2/3 muon was spawned by 2/3, and the other muon was spawned muon 1 was spawned by muon A was spawned by 2/3, and muon B was spawned by 1/3. In a dimension, there's the function will be psi psi the magnitude of psi is equal to 2/3 alpha 2/3, which is a bracket notation, plus 1/3 beta, 1/3 beta. Now, I'm expressing this as a bracket notation because the bracket notation is a formal way to do it in kind of on a block sphere, and because they are it's not spin up spin down, it's because they have their compound direction. There's a compound direction in the ring. There are probably the shape properties. The goal is to have the dimension dictate what the responsibility is. So you can define the codec of the system. For example, let's go to the fabric of space-time. So these are all called fabrics of space-time, fabrics of reality. So the Higgs field is one fabric of reality. That's a for giving proof the math. I don't know any other, but there are others. So my calculation is we have three x coordinates, we have three fabrics of space-time we can observe. So we can observe. I can, right now I'm in a space, and this space has a longitude, a latitude, and an altitude. Those are XY, we call XYZ components. But these components are longitudinal, and altitudinal. So longitudinal, XYZ, XYZ. You can observe two at any time, two at one time, at any one time. So you can take a measurement of a Y or X or X or Y or based at any one time. At any one time. And you can have things you can observe, things you can't observe, which is basically IK principle. So you're gonna have 1/3, which is really 1/3 mapped to 3. So because if you occupy space of 3, you have some dimension of 1/3 in time or space that resolve heterogeneous homogeneously. This space and time is like a mapping between the space and time of the dimension. So you're gonna have 1/3 implies 1/3. I don't know how to formalize this per se, but the 2/3 spin. So you have a 2/3 spin. So when you drop the muon, when you do a muon turns the Higgs boson, it starts to slow down. Because it has a certain behavior, characteristic that detects a behavior that's based on responsibility of the dimension it's operating in. So 2/3 of a muon plus 1/3. What's my next stage? Hold on, this one's I'm trying to do the algorithm here. And you're gonna have 1, 2, 3. So the one with 1/3 of 1/3 D, 1/3 of dimension. At any in time implies you can see two in fact there's three because 1/3 maps 1/3 maps implies 3 in space of space. So 3 plus 3 is 6 total dimensions minimum. Then you have 3 times 3, which is 9. 9 plus 6 is 15. So you have 15 total dimensions you're operating on. So there are 15 dimensions you cannot observe that you may be able to you can access for information. So it goes to different sort of quantum encoding that dictates how the quantum of observability. So you can have things like teleportation, because the systems, whether they are radio waves, radio systems, or operates on kind of a force. So because force operates in one dimension, Gravity opens taking a measurement. So basically, think of orthogonal dimensions as axis. So the difference, because they have orthogonal dimensions. So gravity and something else has orthogonal dimensions, and those dimensions, because they're orthogonal, respect some kind of principles of the system that's operating on, and those have some duty of responsibility. So SAG. So SAG has responsibility to do something of the system. So for example, a 2 spin doesn't mean anything unless it's in a dimension. So 2 spin of a muon on a Higgs field will be because it's gravity will be a down spin. So 2/3 down will imply to down spin. So down spin, so the down spin will be pulling, it has a pull force. An up spin will be a push force. And that push force will be the opposite of up, down, and up. So the down spin, so 2 spin down of a muon, and 1/3 spin will spam. This one is going up. So, do you have an effect of on the muon of a lattice of a universal system that respects rotation, reflection, enlargement, and the translation of a system of any kind of system that's being that's trying to encounter work on a Higgs field. So if these spins are based on super on kind of concept of decay, so so you got superposition decay and you got entanglement. So I'm saying that the window of measurement. So it doesn't matter if things are entangled, things are coherently entangled, everything's entangled. There has to be some kind of decay window, and that decay window is basically where you can interact with that system. That's called superposition decay, and I'm trying to frame it as a formal framework too for the quantum field theory model. So I'm trying to spread this naturally. So you have 15-dimensional lattice. These 15 dimensions are things you can see, things you can 3 dimensions of x, y, z, or altitudinal, based on space-time continuum, the space-time continuum via the Buffon universe model. And 3 plus 3 dimension, which expresses that 3 plus 3 is supposed we have 6 dimensions minimum for everything to work and nothing to interact with each other. And we have 3 times 3 maximum. So we share 6 dimensions, because we're entangled with 6 dimensions, because we're entangled with any kind of superposition state. Everything, it doesn't work out kind of incoherent because superposition can entangle systems. So we entangle, so we can entangle systems because we're entangled into a system of superposition. So 3 plus 3 equals 6. 3 times 2 equals 9. And these are arbitrary numbers. These are systems of and 9 plus equals 15. 9 plus 6. 9 plus 6 equals 15. 15 dimensions of that we can access at any one time. About 15 images we can see and 15 images we cannot see. 15 times 15. So we have 15 times 15, which is 225 dimensions we can observe. So, basically, dimensions refer again to the scientific thing realm we're operating on. So, if you're using a Fourier series or some kind of to map to the Codec, so you can perform some kind of teleportation of information via quantum entanglement. Because the information is isomorphic between the 2 dimensions, you can have teleportation. You don't have to shift any your frame of reference even. 55 times 15 is 225 dimensions. 225 dimensions of Gobertian. So this is a quantum field lattice. And quantum 225 dimensions, we have 226 dimensions. Because also quantum don't want to break. You want to break this, you have to have an extra dimension. You can create this dimension if it doesn't exist. It's 226 dimensions really. So we have 225 dimensions we're operating on because we have things you can observe and things you can observe. And or things you can act on. And I'm saying that 226 dimensions because there's one dimension that we're operating on. And this is the one we can always determine that dimension computationally. So as a buffer space. And it's very good, it's a good practice to do this so you don't break your quantum field theory model. So you have the field, which are the Higgs field. I don't know the other name of the field, but I need to find out more of this field. So let me try to do it. So you have the principle of half. So you have a half of a half ratio of 1/x to x. So if you have half a dimension, you're having the problem. You're delegating half of a problem to a dimension. For example, you have two Higgs fields. You're gonna have a separation of principles of concern. So half. So if you have two Higgs fields, you get a half. You get the half operation. You get half one half equal another half Higgs field. So these Higgs fields are determining gravity shared between the two systems of your operator. And you can have doesn't matter the number of particles. You have 1/x. So 1/x to power 1/x given x. Given x, which is a colon, given x, when x is the dimensions of your flow journal. Thank you for watching the video. Like, share, subscribe.